This is 3/4 inch melamine, and the reason I'm using it is because it's the least expensive engineered panel or sheet that I can get locally. That for the longest time was 3/4 inch. We're talking about the 3/4 inch thickness, 3/4 inch MDF, and that is now $45 a sheet. This, I believe I paid $32 a sheet, and I've got some non-aesthetically important projects that I want to get done, so I don't care what it looks like. I just want a 3/4 inch panel that is stable that I could use. So I picked up some of this to experiment with. This is my horizontal belt sander, and I've had it for a couple years now. It's a Hammer HS950. Really nice machine, topic for another day. But the belts that it uses, I've never had a storage spot for them. So as this has moved throughout my shop, the belts have been put here and put there and put here and put there, and they've lived right here for far too long. My daughter is starting to run them over with her tricycle. So today's objective is to make a storage solution for these belts. Right next to the sander is my dust collector, and this looks like a very convenient spot to store the belts because it's right next to it. And also the frame that the dust collection system is sitting on, the dust collector is sitting on, is kind of skeleton in design, so it's wide open and looks like a good structure to build upon. My thinking is to put some type of panel on the front of here with some type of hangers on the top to slip the belts over and have it at a height in which the bottom of the belt is somewhere right here, so it does not interfere with the use of the dust collection drum. On this side of the dust collector, as you can see, I hang my aprons up over here. I have some PPE that I always just drape over one of these rails, and I've gotten in the bad habit of storing a bunch of randomness on top of the barrel, which I don't want to continue. So it would be very convenient if I'm already building a wall over there to build a shelf to go right here for the little bits of randomness, as well as my safety glasses, PPE, and stuff like that. So a wall over there, a shelf right here. I don't have a vacuum table, so I find that just one washer head screw on either corner or a clamp is all that's necessary to hold this down. I prefer screws rather than clamps because I find that the clamps actually compress the spoil board a little bit, whereas the screws have a physical vertical barrier to stop it from shifting as well, rather than just friction from the clamp. This is the cart that I made for my CNC laptop, as well as some bit storage and just various other storage. But it uses two main joints for all of the construction, a mortise and tenon joint and a box joint or finger joint, whatever you want to call it. So here you can see the tenon on the drawer bottom sticking through a mortise on the drawer front. Same with this over here. You have a tenon on the drawer runner sticking through a mortise on the case side. And on this side over here, you can see box joints, finger joints, where the side piece extends all the way through the thickness of the front piece and vice versa. Once you have the material thickness dialed in and you use that material thickness for all of the modeling, for designing the actual components, cutting it out and then assembling it is very satisfying because everything just kind of clicks together, and it's just a very satisfying assembly process. But you need to know the sweet spot for the material thickness to use to actually model on the computer, because you don't necessarily want to just use calipers and measure for two reasons. Number one, the ends or the edges where the calipers can actually fit on some sheet goods is typically a little bit thinner than the center area, so that's number one. Number two, you don't necessarily want to have a one-to-one fit for the sizing, because that could be too tight. You may want to have just a little bit of play, not so much that the joint becomes sloppy, but enough to where it's a little bit easier to assemble. So every time that I use a new sheet good, I'll run some tests to determine the exact thickness that I need to model with for whatever project I'm going to use going forward with that particular material. I'll put it in a spreadsheet so I always have it, but I need to get that done because I've never used this particular melamine panel in this particular way. The average thickness, according to these calipers, is about 0.762 inches, but this is on the edge where it's always a little bit thinner. So I'm going to start the experiment at 0.765 thickness. I went ahead and cut several pieces to do all the testing, and let's talk about the results. So there's a few things that I wanted to test. Number one, the quality of the edge on a conventional versus a climb cut. Number two, the quality of the edge with the bit that I'm using. Number three, the size of the width spacing of the mortise based upon the tenon, which will also correlate to the length of the tenon. And then also the edge, what can I do to the edges to make them a little bit more durable. I don't want these sharp edges on something that is just going to be exposed. I'm not putting solid wood edge banding on this, so I want to make this a little bit more durable, and I think a simple round over will solve that. So what bit can I use to create a nice round over without it chipping out? So a few tests, but let's just jump right into it. This is my gauge block, I guess you could say, with different sizes. I started with 0.765, 764, 763, 762. These are all inches. And then one open-ended slot right here, because sometimes these fit a little bit differently than mortise and tenon joints. So this is the male piece to this, and I'm going to do all of these I'm going to show you them with it seated just like this, not seated all the way down. So the way I'm going to test this is it's partially seated, and if I'm not coordinated here, there we go. If I put it in just a little bit and just wiggle the top, that's how much movement I have. A little bit more than what I want. So I'll go to the next one, 764. Barely started in the joint. It's better, but still a little bit of wiggle. 0.763 inches. This one, I think, is the money. So it's, again, just barely in there, and little to no wiggle, very little wiggle, but at the same time, you can seat the joint properly. So 0.763, I think, is the number. Now, I did this slot at 0.765. It fits just fine, so I'm going to slide all this away and talk about this little slot joint. I cut another one at 0.753 after getting the information from that first piece, and this is the mating piece. And what's cool about these joints is they slip together kind of like Legos. And this right here, that is so satisfying. Just a nice, perfect joint. But what I like to use these for, these particular style joints, is when you have gravity working in your favor. So in this case, a slip fit is okay. There's no mechanical fasteners necessary if this goes with gravity. So gravity is going to push this down or keep this pushed down, and this would work well with something like an arm sticking out quite a bit like this to hang the belts. So I think this is the style of joint that I will use for the belt hanging on top of the piece, or on top of the project, and then these mortise and tenon joints will be used for the shelf to vertical piece connection. Oh, also, this is the first one that I cut, and I screwed up by making them all the same size. I forgot to offset them. But I used this piece to test the round over, and just a basic round over bit that I already have works just fine. And I think the round over will be a little bit more durable long term to prevent any type of damage if something was to just bump into the edge. You see there, I damaged this one, but I didn't damage this one. So that round over, I think, is actually pretty functional. Here in SketchUp, I already have the stand and the dust collector. This isn't 100% perfect, the dust collector isn't, but it's close enough, and I downloaded this from the 3D warehouse. I modeled this really quick, not much to it, just a bunch of rectangles, but I can use this to determine the exact sizes of all my pieces. So I know my material thickness is 0.763, and I just need to model within the constraints of this particular model. So I'm going to make the bottom shelf, and I want this bottom shelf to R for rectangle from this back corner to this front corner, P for push pull, and I'm going to push this up by the thickness of 0.763 inches, enter. Everything has to be 0.763 inches for the model to be accurate. I want this shelf to actually extend out by just a little bit, so I'm going to give it 1 inch, and I'll put a little radius on there once we get into V-carve. Now, one thing that I do need to do is create a big U shape to go around this, and I haven't taken those measurements yet, but I'll do that right before I transfer everything to V-carve. No need to show that. The front piece right here, R for rectangle from this corner to this corner down here, P for push pull, and I'll pull this out by the thickness of, oops, let me back up, Control Z to back up. I forgot to make this a component. So let's spacebar, triple click, G for component, enter. Now I can do this. R for rectangle from here to here. P4 push pull, and I'll pull it this direction, 0.763 inches, enter. T for tape measure, and I know that I have like a 48-inch length inside the belt, so I want the bottom of the belt to be here, which means the top needs to be about 48 inches. So I need to P4 push pull, and it's extend this top face to this line right there. Spacebar, let's grab that and press delete. That's the basic gist of the structure. Now we need to add the connections here. So let's spacebar, triple click, G for component, enter. H for hide. I no longer need to see that, and I'll double click to edit this part, and I need to add some box joints here. So let's just go with R for rectangle, and let's see, just drag it in this direction, and if I snap to this bottom edge, all I have to do is type in the first dimension, which is the width here. Let's do 1.5, enter. Let's do 2, enter, and then 1.5, enter. So now I have these three that I can hold shift to select, M for move, control brings up copy, and let's hold shift to constrain to the red axis and drop it off over here. P for push pull, and let's pull this out by the thickness of 0.763, enter, and double click to repeat my last push pull on these fingers. Let's click to get out of our part, U for unhide the front, and now we have something we can trace. So let's double click to edit this front piece, R for rectangle, and let's just trace these. I can grab this, M for move, control brings up copy, right there. And grab both of these, M for move, control brings up copy from here to there. And now P4 push pull, I'm gonna push this in the backwards direction, stopping at the thickness. And I can double click, and double click. Just to give it a little bit of contrast so we can see the intersection, so we can see these two pieces interacting with one another, I'm just gonna throw some color on here. And now you can see the mortise and tenon joints for the shelf to the vertical piece. Now these connections, I'm going to put a screw right in the middle to connect to this piece. So I will also have the screw itself acting against gravity to stop this panel from falling down. I think that should be plenty enough. Just those 4 mortise and tenon joints and 2 screws. Now what's to stop this thing from falling in this direction? Well, we've got a connection there, but I'd like to make some hooks that go around this. And I can do that in 2 ways. I can do a mortise and tenon joint through here, secure it with a screw, and then just make a hook that comes down. Or I can come from the side and make a hook that comes around all of this stuff. That'll reduce the amount of mechanical fasteners. There's not that many in this case, so I'm just going to go ahead and do the mortise and tenon joint. So let's go with the camera parallel and then go to a right view. So now I know that I'm in a normal to orientation, and we will go with L for line, come here, and this is 1 1/4 inch square tubing, but I have some tabs right here, so in all honesty this is more like that. I haven't taken that measurement yet, so I'm just going to assume that that's about a quarter of an inch, and I will just add the extra back here. Now if this is too much of a gap right here, I can shim it with tape or something. This is just a one-off, so it's not that important, but this will all make sense in just a minute. So L for line, let's come this direction, holding shift to constrain to the red axis, or I can just press left on the keypad. And let's go with it's 1 1/4 inch square tubing, so let's go with 1.5, enter. And then we'll go down, making sure the blue axis is selected, and we will go down. Let's see, it's 1 1/4, like I said. So let's just go with 2 inches, and over by 1 inch, just for some material mass. And did that. Okay, I was just making sure that this didn't snap to the background here. Let's go back to this. L for line. You know what? Let's just go ahead and hide the cyclone. We don't need to see the cyclone. L for line, and let's go up our initial 2 inches plus 4 inches. So let's go 6. Just making this up as I go. Hold shift to go over to here and then down to here. So now I have a piece that I can P4 push pull, and go this direction by the thickness of 0.763, enter. Spacebar, triple click G for, spacebar, triple click G, not H, for component, enter, M for move, and I'm going to move this in to the inside of this and then just give myself a little bit of leeway by going in 0.25 inches. Now I need to add the mortise and tenon joint, so let's go ahead and hide this front piece. Double click to edit this part, and R for rectangle. Let's go this direction by 1.5, enter, and grab this, M for move, control brings up copy. What does that leave me in the middle? That leaves me 1 inch in the middle. That's fine, I'm going to put a screw right through that. So P4 push pull, and I'll pull this out by the thickness, which is 0.763, enter, and double click to edit to copy that. I'm going to add roundovers and all that once I get to the CAM software. Let's go with U for unhide to bring this back, and I need to put one over there before I add the mortises. So let's back up so it's still hidden. And let's grab this, M for move, control brings up copy. I'm going to press the right arrow on the keyboard to constrain to red, and I'll drop it off right where this other member is, and I'll push it back that same 0.25 inches, enter. Now I can unhide. Now I can double click the green piece, R for rectangle, and I'll draw my pieces here. M for move, control brings up copy. P4 push pull, and I'll double click, whoops, wrong direction, control Z to back up. Let's push this direction, constraining to this back edge, and there we go. So that should work. And you know what here? I think that there is room for a measurement conflict. Let's just say that whatever this measurement is, what do I have here? The space in between, the space from here to here I have at 27 3/8. Let's just say that it is 27 5/16. It's just less than that. Well, one of these two is going to hit and not the other one. So just to guarantee that all the weight will be on this bottom shelf and not these up here, I think I'm going to elevate these by 1/4 of an inch, and I'll still get the mechanical connection here to prevent rotating forward. So let's grab both of these, M for move, and let's move them up by 0.25 inches, enter. And I can do the same thing with these mortises. Let's double click to edit this part. Use a window to select all of them at once, M for move, and let's move them up 0.25, enter. So that looks like the structure complete. Now I need some hangers for the top piece. And that's where I wanted to do those kind of like a slip fit, those slip connections, slip joints. So let's just go ahead and go back to the right view, and let's draw this L4 line from here to here. Let's go down 1.5. That sounds good. Come over 1 inch, enter. That sounds good. And we're going to go up. Let's see, I'll just constrain to this and then an additional 2 inches. And then we'll constrain to this. So now I'm at the front of the piece and I need to go an additional, they're 6-inch wide belts. I'm going to go 7 inches just in case they're not laying flat or whatever. 7 inches, enter. We'll go down 1.5, enter. We'll come over all the way to, I'm going to add more and then just start subtracting lines. It'll make sense. I'm just trying to use these snaps to measure from. So I'm all the way at this point. Let's go back by 1.5. Let's go back by 1. And then from here, let's go down to, let's see, what is this measurement? Down to bottom right corner of the screen says that's 2. Let's go down 3 inches, enter. Let's come over to here, back up to here, and there. So I should have, if everything was done properly, or if this was all traced out, which I'm not sure if it was or not. There it goes. So now I have this shape. Let's add a little bit of radius to it. I don't know if I should draw an arc here in SketchUp. The reason I don't like putting arcs or anything with a curve in SketchUp if I know I'm going to the VCarve or the CAM program is because all of your circles and arcs in SketchUp are segments, not true circles. And sometimes that does translate, sometimes it does not translate to circles when you import it into VCarve. So I'm not going to. I'm going to actually add a radius to this so it looks a little better. I'll round over all of these. But that's the shape of the bracket. P4 push pull. We'll go this direction by 0.763 because I used a bunch of segments to make these other lines. I've got this other stuff to deal with. And spacebar, triple click, G for component, enter. M for move, and we're going to grab this, press up to constrain to the blue axis, and drop it off right there. So now let's come in. You know what? Let's start from the other side because I think I don't have enough room as it is. And let's come in by 1 inch, enter. And then from there, M for move, control brings up copy. Let's copy this all the way to here, move it over 1 inch, enter. Now I want to divide these out, and I could either put a little line here. There's two methods to do this. First, I could give myself an endpoint to snap to, right? So then when I grab this, M for move, control brings up copy, I can stop it on that endpoint and then press like divide by 6 and then get even spacing. But I never add these. What I end up doing, let me back up. What I end up doing is putting my start, putting my finish, and then just doing it once more. M for move, control brings up copy, put it right there, and then press divided by 6. That gives me 1, 2, 3, 4, 5, 6, 7. I think I have 8. So let's press divided by 7. Now I have 8 evenly spaced, but because I copied one, I've got a duplicate over here, so I'll just click and delete. Hopefully that made sense. What's the spacing in between here? 2 and some change. So I'd like to do probably more than what's necessary. Actually, you know what? I can just add some over here. The filter stack is on this side, and it can be moved anywhere. On this side, if I have something vertically hanging, it's going to get in the way of the sander. So on this side, yeah, let's just do that. Let's just add some more space over here. So let's grab this. Let's grab this corner right here, this edge. M for move, control brings up copy, and let's copy another one down 12 inches. P for push pull, and let's pull this out in this direction, I don't know, 10 inches? 8 inches? We'll just do that. Just give us some more space over here. All I need is another hook up here. That's fine. The filter stack is right there. So now let's redo this spacing. Let's move this over to here. Let's move it there by 1 inch, enter. Let's go top down so I can grab all of these and press delete. Let's grab the first one. M for move, control brings up copy from here to there, divided by, I already did 7 rather, so I had 8. That's divided by 8, so I have 9. 9 should be more than enough, and that gives me some extra space in between, up to 3 inches. That sounds good. I like that. So now I need to make the slots in the green piece. Let's double click to edit the part, and we're going to press K for hidden lines. So you may or may not be able to kind of make this out, but you see the hidden lines of where these two pieces intersect. So I can press R for rectangle and start right there and end right there. And if I press Y to hide everything else, I think that's a custom keyboard shortcut, but as I'm editing a component, I can hide everything else. So you see that rectangle that I just drew, and I need to cut this away as a slot for this to slide down from the top. So I'm still editing the green part, so if I click here, I'm actually selecting that face that I just made, that rectangle, not this white piece. M for move, control brings up copy, and I'll grab one right here and set it right there and press X9, enter. Whoop, that's too many. X8, enter. And now I have all my slots drawn out. Let me press Y to hide everything else. Once again, P for push pull, double click, Control Z, I forgot I did some other stuff. So let's P for push pull, let's push it this way, all the way through, and now we can double click to get rid of all of this other stuff. Press K to turn off my hidden lines, press Y to bring back everything else, and click to get out of the part. So that's basically it. Kind of an odd design. Definitely a one-off for this particular situation. but this will give me something to mount all of my belts to at the top. There's no screws or hardware necessary for these connections. They'll slide in from the top and gravity will keep them in place. I will put one screw in between these mortise and tenon joints for the hooks onto the rack there, the stand. And I will put one screw in between here. I will take the measurements for this cyclone and then just make a U shape to delete this center section. I'll do that off camera, and then I'll meet you over in V-carve. As you can see, I added the horseshoe cutout, or the U-shaped cutout around the cyclone. And there's one final thing that I forgot to do before we go to V-carve, and that is put everything on its own layer, or now called tags. I'm using Sketchup Pro 2021, and they've changed, I don't know what year they did this, but they changed the layers to tags. Same thing, different name. So what I want to do is only select all of the CNC components. For me, I've already got everything else as a group, so I'll just hide that. Select everything that I want to have CNC cut, and I will create a new tag or layer, and I'll name it CNC. With everything selected, I can go to Entity Info and change it to the CNC layer or tag, and that's it. I just need to save this file. But what the layers or tags do is they allow you to import only that specific layer or tag. So I have other stuff in the model, that's fine, it's not going to be imported. So I'll go to File, Save As, and as you can see, I've already named it Sandpaper Rack. I've already saved this, but I'm going to save this as a Sketchup version 2017. My particular version of V-carve Pro requires 2017 or older files from Sketchup to be imported. So I'll save it as Sketchup version 2017, and I'll actually make notation in the file structure of SU2017, 2017. Press save, and now I can go into V-carve Pro. So this is my file in V-carve Pro. A couple things to note here. I have a 10-foot long machine, so the whole white area is 10 feet long and it's not quite centered. I have a vertical table up front, so this red boundary is the sheet that I'm working with. Let's turn off some stuff that's not needed. I'll turn off the dogs and the plywood. So this red boundary box is the sheet of melamine that I'm working with. Now, as far as all this stuff that's already on here, this stuff you already saw me cut out. This is the testing that I did. This stuff you didn't see me cut out, but this is stuff that I got distracted with and was playing around with while making this video. So while this doesn't pertain to this project, I did cut some stuff up on this sheet already, and that's the result of that. So disregard this, but I need to keep it here because, well, that space is already called for, already taken care of, already designated. It's already been cut out. There's a couple different ways to import the SketchUp file. You can go to your drawing tab and click on this import vectors button and just find the file, but I typically already have the folder open every time I'm working with this stuff, so I just drag and drop SketchUp 2017 file. And from here you get a couple different options. The only two that I really care about in this case is auto orient the largest face on top, and then import only visible data on the selected layers of CNC. Press OK and it imports. I'll press hold shift and move with the arrows, and it looks like I won't be able to get it all on here. Is that real? Is that for real? Did I goof up? Oh no, I goofed up. All right, that's what you get for getting distracted and cutting some other stuff like I shouldn't have done. So, what's more important? I think getting everything on this sheet is more important than having this space right here in front, because the first, darn, that sucks. The first solution is to just break this horseshoe piece into two side pieces, and then that should fit no problem. Oh man. Oh well, I guess that's what I get. One thing to note is, if you see a solid line, that's a group. If you see a dotted line, like these are dotted lines, that is not a group. That's just a closed vector, or a selected vector, I should say. For modifying this, I need to U for ungroup it. Actually, I need to ungroup everything so I can put fillets or radiuses in the corners. So U for ungroup. Keep in mind that I did ungroup it. So if I go to move this, 1, you know, move this, it's not going to move. The inside is going to be independent now that they are ungrouped. So don't accidentally move one and not all of it. I was just moving it back and forth with the arrow key, so I didn't change its position. I need to break this up. There is a gadget called Explode Vectors. So this is just one solid closed vector all the way around, but I can break it up into a bunch of different line segments. So I'm going to do that. Gadgets, Explode Vectors, and I'm going to delete this center section here. We're going to add a line from this endpoint. Right, why is it not snapping to this endpoint? Add a line from this endpoint. There we go. Snapping to that endpoint. And I'm gonna go a little bit further just because it's easier to do that. I gotta use the trim tool to trim this back. Delete this other one over here. Now I have a bunch of independent vectors that I have to join together. So I'll select this, press join. It says that the vectors after joining will be one closed vector. That's what I want. So now I have a left or a right, and I need a left. So Control C for copy, Control V for paste, and I'll just use the arrows to move it side by side. The top and bottom sheet of the melamine are the exact same, so I don't necessarily need a left and a right, but however, it's just easy to do with H to flip it horizontally. Now I have a left, now I have a right. And now this should be able to fit basically anywhere. Yeah, there we go. Basically anywhere with no problem. Now there's kind of a rule in CAD, which is you don't draw what you can copy. For the majority of times, it doesn't make sense to draw anything that you can copy. Copying is always faster. Why do the work multiple times? So I have a bunch of copies here. As a matter of fact, that's 5 and 5. I've got one too many. I think I only needed 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, so I have too many here. I'll go ahead and delete one of these. So never draw what you can copy, meaning I'm only going to modify one of these, and then I'll copy as necessary. It doesn't make sense to modify all of them. And then, yeah, that's that. Let's do first just the regular radiuses or regular fillets, roundovers on the edges. We'll change, we'll go with a normal fillet, add this to, let's just say we're going to go with 0.5 as the standard radius for all of these. The big panel, all 4 corners here, 1, 2, 3, 4, can be the 0.5. I want to add just a little bit more of a sweep here. The front 2 corners on both of these shelves, those are 0.5. This is the holding bracket. I'll put a 0.5 there and there. And one up top. That's fine. This is the hanger for the actual sandpaper. 0.5, 0.5, 0.5. I want to add a larger radius here. 0.5 and 0.5. That sounds fine. Let's change this larger one to, what does 2 inches look like? That looks fine. One cool thing about this fillet tool is if you've already made a fillet, you don't have to go back in there and delete it and redraw the corner to do a different size. The icon, you can see the cursor changes to an X, and that cancels. You can add, cancel as you change different sizes. And that's just very, very convenient. Let's add, what are we at, 2 inches? Let's see what 2 inches looks like here. That looks fine. Looks a little bit more finished. Now I need all the dog bone fillets. So there is a tool here, Gadget Dog Bone Filleter, and you can select all the kinds of stuff and it'll do all of your interior corners based upon your specifications and dog bone them all at once. However, I want to show you the slow way, just because there's not that many and I can get them done pretty quick. So you can go to Fillet, Dog Bone Fillet, and change your tool radius to whatever the radius of the tool is. I'm using a 1/4 inch diameter bit, which means the radius is 0.125 inches, but I always do 0.13 just to give a little space. No need to be exact. And the reason why you need a little bit of space here is because this is a mortise and I'm using a round tool to create the mortise, so I can't get crisp corners, crisp interior corners. However, the pieces that are going to go in them will have crisp corners. So what I need to do is add a little bit of leeway on, or a little bit of room for that sharp corner to actually come into play. So all this does is as the bit comes down, it just goes in a 45-degree angle basically to create a little bit of extra space on all of these interior corners. It's called a dog bone fillet. And there's a couple different styles. There's a T-bone fillet that doesn't go on a 45-degree angle. The T-bone goes to the side in either direction, doesn't matter, and that gives you that same interior 90-degree corner. I just prefer the look of dog bone fillets, so that's the route that I am going. And again, never draw what you can copy. However, there's not that many of them here, so I'll just go ahead and swing through this. I also, if I've got a few to do, I like to do them in rows and columns versus going around a single part, just because it's less direction change with the mouse. So knock these out really quick, and there's not much to do after this piece, because remember, all of the above pieces are going to be copied. I need 1, 2, 3 per shelf here, and you kind of get a visual feel for this after you do it a couple times. This is the bracket hanger, and these are the sandpaper hangers. So these need it right there as well. Now, again, never draw what you can copy. I don't know why I did it up here. That's the copy one. So I'm going to delete this one, grab this, Control C, Control V, copy paste, and we'll put it up there. Now we have 9 of these to do total. So delete those, copy paste, and now I have 2. Copy paste, now I have 4. Copy paste, now I have 8, and we'll just get one more, copy paste right there. So now I have my 9, my 2 hangers. I have all of my parts, and they are done. Before I nest this, I want to make this into a group, because I don't want this to move around independent of the mortises that are inside it. So I'll select all of this, G for group, and now I can use the nesting tool. But I want to specify where the nest actually is. I wouldn't really have to use the nest tool. I can bring this down here manually, and it's pretty simple enough to get it done. But it's cool to use the nesting tool, and I want to show you that. So what I'm first going to do is create a boundary for it to go into, because I do have some other stuff to be in the way. So let's go with something like this, and say that this closed vector is my boundary box. So I'll select this first, hold shift, and then select this. It's important to select the boundary box last. Press the nesting tool and check this box that says last vector is nesting boundary. I've got a bunch of different options here: the tool diameter, the clearance in between parts. I'm going to change that to, I've got plenty of room, so just 0.5. Border gap of 1 inch, because I don't want them to be right at the edge. And auto orient the parts, 45-degree angle, sure, whatever, X and Y. You can change all this stuff. Click preview, and it'll automatically put it on there in a nice, efficient way. Now this gives me a long strip. What's going to be more beneficial, a long strip or a wider, narrow strip? I think a wider, narrow strip. So you can change X or Y. Press preview, and I think I like this a little bit better. It gives me a little bit more extra space, I guess. I don't know. In this case, it doesn't matter. We're splitting hairs here. So auto orient is done from the nested parts. Press OK. Now I want to do different tool paths with this and with this. So I'll U for ungroup it, and I've already got some vectors or some tool paths from this testing stuff that I've already done. So what I can do instead is just open this up and change what I want. These are the pockets. So I'm going to use a pocketing toolpath to remove all this stuff. That way I don't have to worry about tabs and small pieces flying around. That's fine. Small stuff, we'll get rid of those. I'm using a 1-inch length of cut bit, and I have my cut depth set to whatever the Z is plus 0.01. So I'm going to cut into the spoil board by 0.01. And EM25 pockets. I always name my tool paths the tool and then what it is. EM250 means it's an end mill, 1/4 inch. Pockets, there we go. Nothing much to specify here. Oh, one thing to consider is I'm using a compression bit that has a shallow upcut right at the bottom of the bit itself. Sometimes if you don't specify whatever depth the passes are, it will automatically adjust them as necessary. So let's uncheck this right here. So now I have evenly spaced. It took all the entire depth and divided it by 4 based upon my maximum depth per pass. and that tells me that some of my pass depths are actually lower than the compression, so I won't get that compression effectiveness on my particular bit. So what I want to do is maintain the exact tool pass depth. So instead of distributing it by 4, it's going to give me my specified 1/4 inch depth per pass, and then the last one's a super tiny one. That's fine. I just want to make sure that my first cut is lower than the height of my upcut in the compression bit that I'm using. Hopefully that makes sense. So that's one thing to note here. So those are my pockets. Let's press calculate. It'll give me an error saying I'm going to go a little bit further than the material thickness, and that's fine. I'm going to go into the spoil board. I know that. Let's press close. I have my set to where it doesn't close that window automatically, by the way. And now I can go to the perimeter, which is this box that I was testing, and I can select different vectors. We'll get all of this. I'm holding shift to get all of this, and I'm going on the outside. This is a profile toolpath, again Z plus 0.01 for the cut depth. Same bit. Once again, I made sure my edit passes are set so that they maintain an exact tool pass depth of 1/4 inch. I did add, I did add ramps, excuse me, ramps, so it doesn't plunge, and I am going to add tabs, and I'll simply just go to constant distance between tabs, 8 inches. Sure, that's probably too many, but I have no complaints with that. One thing that I do want to do is make sure that none of these are down inside the small little areas of these notches here. So the number of tabs is fine, and the majority of the placement is fine. I just want to make sure that it's in a more convenient location to cut off with my method of cutting the tabs, which is one of those oscillating multi-tools. I think that's it. So let's press close with the tabs. Let's go to calculate. It's telling me I'm going into the spoil board. I know that. Press OK. And if I zoom in, you can see the dotted line is the vector on the right side. Left side is the bit travel, which is correct in this orientation. And then these green areas are the tabs. I like to make my tabs 1/8 inch long and 1/4 inch tall. That's basically for all tabbing operations that I do. And that's it. I want to cut the pockets first and then the perimeter without stopping. So I'm going to save this as save visible toolpaths to one file, and I'll click save and load it up in Mach 4 and then go ahead and cut it out. Looks like I goofed up staging this shot to clone myself in, so let me go ahead and draw a line, and then I can delete the background over there, then I can put the actual CNC working underneath it so it shows up, and now we can begin. So first off, the estimated time to make these cuts on the computer was 16 minutes and 21 seconds. There's a value you can change, or a multiplier that you can change to really dial that in. 16 minutes, 21 seconds estimated. The actual time to cut this was 15 minutes and 51 seconds. Now that is at a non-optimized tooling setting. I just used my standard setting. But if you are in a situation, or if this was a manufacturing situation where time is money and you're trying to just batch these out as much as possible, there's many areas where this could be tweaked. You know, first off is the feed rate. For the pockets, I don't know why, but my tooling for the pockets was set at 150 inches per minute, and all of the profile cuts was set at 300 inches per minute. I've really pushed this machine to see what it can do, and I'm confident at a full 1/4 inch depth of cut on this material, because there's not much resistance, I can get away no problem, I'm confident, at 500 inches per minute. Now, for the smaller sections where the pockets are, the mortises, you're not really going to have as much time or as much distance traveled to actually get to 500 inches per minute. So it may not make much sense, or you may not see much improvement with smaller areas like that. But for all these profile cuts, majority of the segments in these profile cuts, you can see quite a bit of improvement by increasing that to 500 inches per minute. So I put those two values in, and the estimated time went from 16 minutes 21 seconds down to 10 minutes and 19 seconds. You do the math to figure out what the actual would be, and increasing it to 500 would go from an actual 15 minutes 51 seconds to an actual 10 minutes even. So 5 minutes savings on that entire job. If you're doing this over and over and over and over again, you can see how that could be very beneficial to speed up the process. And that's just one of a few different ways, like nesting, that can increase or decrease the overall time of the cut. Next, all of the pieces can be cut free by cutting the tabs with an oscillating multi-tool. Then all of the tabs are removed at a router table with a flush trim bit. And finally, most of the edges are eased with a 1/8 of an inch roundover bit. As of right now, I don't have any screws. Oh man, I left something up there. I don't have any screws in this, but it's held together quite tight with the joints. And I forgot to move the filter stack. So let me undo the bungee on the filter stack and try not to knock anything over. Now what are we on? Okay, we gotta put the clips over the top, spin this side in, and voila, that worked out really good. Spacing right there is, oh, that's perfect. That couldn't have got any better. That's luck. All right, now let's put some screws in this thing. Switching over to my cell phone to wrap this video up. It's just a little easier to walk around with this. I am very excited to get that done. Simple stuff like this, right? Those belts I've just been moving around and around and around for 2 years or so, a year and a half, and they've always been in my way, and well, it's about time I do something with them. Simple project. Hopefully you enjoyed the engineering process or the design process for this solution. And hopefully you got something out of it. I think that 2 shelves instead of 1 that wraps around is still a big win in my book. Mainly just wanted to stop putting stuff on here, get in the habit of not putting stuff on there. Mainly my spray bottle for water, and then my bottle for sharp objects. I'd rather fill this up and throw this away with all the sharp stuff in it, rather than putting screws, nails, and that type of stuff into the trash bin by itself. Just less opportunity for flat tires with that. Anyway, very clean install. It's not secured at all. It's not fastened at all to the stand. It's just held in place by gravity. I think it's plenty strong enough to do the job as intended. Anyway, thanks for watching. You guys take care. Have a great day. I'll talk to you in the next video.